हाय फ्रेंड्स, हम आज लैप्लास ट्रांसफॉर्म के थ्योरम 7 देखने वाले हैं। थ्योरम नंबर 7, दैट इज लैप्लास ट्रांसफॉर्म ऑफ इंटीग्रल। दिस इज सिलेबस ऑफ BSc सेकंड ईयर. I almost all syllables give in some videos. So this is paper second of mathematics, that is integral transform. Paper name is integral transform. Then there are second chapter. First chapter I already give some videos. Then second chapter there is theorem number 7, Laplace transform of integral. If a Laplace transform f of t is equal to f of s, then 1 upon f of s into f of 1 upon s into f of s is equal to Laplace transform of integration 0 to t f of u into du. So proof, we prove this and given is this. So proof is let we also know. First in proof, first we write given. So let given is Laplace transform f of t is equal to g of s. We replace f of s by g of s, and g of t is equal to integration 0 to infinity f of u into du. Here is we give g of t is equal to integration 0 to t f of u du. Then we were to prove that we prove that you and me prove that this. So from first this is clear that from first this is equation number first. We clear that when g of t is 0, so then f of 0 du, so that is equal to 0 also. Here we write g of 0 is equal to what is here 0 to integration 0 to t f of here u is 0, so here is also 0. So then this is also equal to 0. Then g dash of t, g dash means derivative, their derivative, dash means their derivative, d by dt, that is integration 0 to infinity f of u du. But we know integrations and derivative both are opposite, so integration and derivative cancel, and their limit we put here limit. F of 0 is already 0, and then f of t remaining f of t. Then by theorem 6, we know the theorem 6, that is Laplace transform of g dash of t is equal to L f of s minus f of 0. The theorem is s f of s minus f of 0. The theorem Laplace transform of f of s, f dash of s is equal to, this is theorem we give in first before these videos. So Laplace transform g dash of t is equal to s, here is f of s is g dash of t, g of t, not g dash, g of t, minus f of 0 is g of 0. So Laplace transform of f of t is equal to Laplace transform of g of t minus 0. Here we find f of u means f of t. We replace not we replace only. So f of u is 0, so g of 0 is also 0. So Laplace transform of f of t is equal to Laplace transform of g of t. If f of s is equal to Laplace transform of g of t is also equal to, here we find g of here we find g of t. Laplace transform of integration 0 to t f of u du. So this is our proof of the theorem. That is, here is proof. What we can prove, that is 1 upon s f of s is equal to Laplace transform of integration 0 to t f of u du. Here we prove 1 upon s f of s is equal to Laplace transform of g of t. Means g of t means g of t, here g of t. What is g of t? Laplace transform of integration 0 to t f of u du. So next theorem is this is next multiplications by power of t. Means what here this theorem is about power of t. What is power of t is n theorem. If Laplace transform of f of t is equal to f of s, then Laplace transform of f dash of t, Laplace transform t raised to n f of t is equal to minus 1 raised to n dn by dt raised to n of f of s. We have to prove this. Multiplications by power of t. Multiplication means power, t is power n. So for n is equal to 1, 2, 3 up to nth value. So then their proof is let Laplace transform of f of t is equal to f of s. This is given, and d raised to n ds raised to n f of s is equal to f raised to n of s. Means we know here I say f dash of s is equal to d by ds of f of s, like this nth term, that is dnth by ds raised to nth f of s is equal to f raised to n d of s. Then f of s is equal to integration 0 to infinity e raised to minus st f of t dt. This is Laplace transformation equation. We see in up to first theorem to up to end. So d by ds f of s is equal to, so here is derivative, so take both side derivative, then d by ds is equal to d by ds integration 0 to infinity e raised to minus st f of t dt. Take this derivative under integrations. So this is equal to integration 0 to infinity dou by dou s integration e raised to minus st f of t ds. So take derivative of e raised to minus st. So derivative is minus t e raised to minus t e raised to minus st. This is derivatives of e raised to minus t e raised to minus st, and then here minus t is constant, so put outside the root. Then this is also equal to Laplace transform of f of t. Here is e raised to minus st, so this is also equal to Laplace transform of f of t into t raised in t into f of t. Laplace transform of t into f of t, and here is minus transform here, so minus 1 d by ds f of s is equal to integration 0 to infinity e raised to minus st t f of t. So this is Laplace transform of t f of t. Then or minus 1 f dash of s is equal to Laplace transform of t f of t. This is simplificative. This proves that the theorem is true for n is equal to 1. Let us suppose that the theorem is true for n is equal to r. Then we prove this theorem is true for n is equal to r. Then r means 1 2 3 4 5 6 up to r plus r plus 1 r plus 2 up to n. R is midpoint of 1 to n. Okay, so minus 1 raised to r, here is 1, so here we give r f raised to r of s is equal to Laplace transform of t raised to r f of t. So Laplace transform equation is integration 0 to infinity e raised to minus st t raised to r f of t dt. So here we give derivatives. So here we give derivatives. Here is first derivative, here is r the derivative, then 1 add there, so r plus 1 derivatives of f of s is equal to under integration 0 to infinity dou by dou s e raised to minus st t raised to r f of t ds. So give derivative of e raised to minus st, so minus st is here is minus t e raised to minus st t raised to r f of t dt. So here is t and here is t, same base, so adding both, so this is equal to t raised to r plus 1, t raised to r plus 1. So this is the Laplace transform of t raised to r plus 1 f of t. So Laplace transform of t raised to n of f of t is equal to minus 1 raised to n d n by ds raised to n f of s for n is equal to up to n 1 2 3 4 5 6 up to nth term. Okay, then we have to give some example, that is the example is Laplace transform of t square minus 3t plus 2 into sine 3t. We know the Laplace transform of sine 3t. Laplace transform of sine, I first write Laplace transform of sine 80 formula. First formula is Laplace sine 80 is equal to a divided by p square plus a square. This is formula of Laplace transform of sine 80. So we use this here. So here a is 3. So put here a is 3. So Laplace transform of sine 3t is equal to 3 divided by p square plus 9. So then Laplace transform here is we know the above theorem. Laplace transform of t into sine 3t when we multiply sine 3t in this bracket. So what we get here is t square into sine 3t minus 3t into sine 3t. So t, so we required here t into sine 3t. We solve solve here. So Laplace transform t into sine 3t is equal to minus 1 raised to 1 d by dp of derivatives of these functions. So these functions, derivative of this function is 3 by p square plus 1. So we know the derivative. We also know here derivatives of p square plus 9 is 1 upon p square plus 9 bracket square, then into p square derivative is 2p. Here 9 is constant, so constant derivative is 0. So 3 into 2 is 6p divided by p square plus 9. Then we required here we find the values of t into sine 3t. Then we also find value of t square into 3t. Here we find Laplace transform of t square. T square is equal to, here for simplifications, t into here we also find the values of t into sine 3t. So only t into t sine 3t means t square sine 3t is simple. So this is also gives here we required t into sine 3t. So here we put t into t sine 3t. We also put t square into sine 3t. Okay. Then t sine 3t's values is this 6p divided by p square plus 9 bracket square. Here only t, so minus 1 raised to 1 first derivative. Okay. Then their derivative 6 is constant, so out of the derivation. Then here is p. We know this derivation, that is first this derivative there is into constant minus second this derivative, this is constant, divided by this square, not derivative, square. So we give this first this derivative is constant, that is for p's derivative 1, and p square plus 9 square remaining as it is we put here minus sign. Then this is as it is, here is p is as it is here. So this derivative is 2 into p square plus 9, and p square derivative is 2p. So then 6, here is 6 we simplify this. Then we find their values of t square, Laplace transform t square into sine 3t, that is 18 p square minus 3 divided by p square plus 9 bracket cube. So we find sine 3t, then t into sine 3t, then t square into sine 3t from equation 1, 2 and 3. The Laplace transform of t square minus 3t plus 2 into sine 3t. This is equal to here adding both t into sine 3t is, here is 18 p plus p minus 3 divided by p square plus 9 brackets cube. Then 3 remaining, and here is Laplace transform of t into sine 3t, t into sine 3t, here is t into sine 3t, 6p divided by p square plus 9 bracket square. Then here is sine 3t, here 2 3 multiply this. Then this is the Laplace this is the values of Laplace transform t square minus 3t plus 2 into sine 3t. So thank you.